Hey mathematicians, here are your notes, 5.1.2, day 2 for slope. So quick bell work, what are the 4 ways we can express slope? If you need to look back on yesterday's notes, go ahead. However, I encourage you to go ahead and try and see if you can get a few of them, or at least one of them, I would hope, without those. All right, hopefully you had a minute to write at least one of those down. The first one, remember, is our variable. We use the letter m to indicate slope. The second way is going to be rise over run. Many of us like to think of it as rise over run because it's short and simple to remember. However, if that doesn't work for you, totally okay. Another way of looking at is vertical change, indicated by vertical delta, divided by horizontal change, or horizontal delta. And last, but very much not least, it is one of the most important formulas you will learn, especially in this specific chapter, is the formula y1 minus y2 divided by x1 minus x2. Remember what I said yesterday, the big important thing for remembering this specific formula is that your y's go on top, your x's go on bottom, and your numbers line up. There's none of this y1 with x2, y2 with x1. That doesn't work for us. They have to line up like this. So today's goal is to be able to define and calculate the rate of change. Go ahead and take a minute to fill out that what I think. Get your brain nice, primed, and ready to start learning about slope for day 2. All right, rate of change, aka slope. That's right. If today's lesson is slope, it makes sense that we're just going to talk about slope with different words, which is rate of change. So rate of change is basically, it's one of those definitions that I don't like because it is essentially the rate at which something changes over time. Not a great definition because it literally uses the words, but it's the most accurate, so that's what we're going to go with. Rate that something changes at over time. And much like the grade problem yesterday, if you remember with the truck, rate of change is just a different type of slope. It's another real-world example where slope is very important, so that's why we're going to talk about it. So what are some examples of rate of change? Well, I think an easy one to remember is your height. Your height changes at different speeds over your lifetime as you go through puberty. A lot of people hit that growth spurt, and that rate of change speeds up really fast. Another one would be gas prices. Those change over time, and they change at different rates. You've got your in-store prices, your clothing prices. Taxes are technically a rate of change. Your insurance. Those are all different examples of rate of change. If you want to put more, go ahead. I'm going to leave it there for now. So let's look at a specific rate of change. A specific Instagram influencer had 12,125 followers when they became verified. 5 years later, they had 10,100 followers. What is the yearly rate of change in the number of followers for the 5-year period? And then explain your answer in the context of the question. So, one of my pet peeves about word problems is that they have a lot of words. I'm a math person. I like numbers. So I'm going to go ahead and pull out some numbers. It says they had that many when they became verified. So we're going to say at time 0, they had that many followers. It says 5 years later, so at time 5 years later, they had this many. Here's my question. If they became verified at that many, why are they losing people after you become verified? We gotta talk about their business practices. Anyway, what is the yearly rate of change? Well, as I said up above, rate of change is just another term for slope. So if I want to find the rate of change over this 5-year period, what it's asking me to do is calculate slope. My unknown is m, so I just remind myself that's what I'm looking for. Now let's go into it. Let's just use the numbers we're given here. We've got an x1, y1. We've got an x2, y2. I'm going to go and use the top one as my first coordinate, bottom one is my second coordinate. So y1 is 12,125 minus the 10,100 divided by 0 minus 5. Calculate that. I get 2,025 in the numerator and negative 5 in the denominator. The negative doesn't matter so much. However, when you look at it, when you look at our answer of negative 405 followers, remember followers per year, so this is negative 405 followers per 1 year. This is why I want you to explain the answer in the context of the question. Even though in terms of followers per year we don't need the negative, it tells us something specific. And the thing it tells us can be seen in the information, but again, if it's there, use that information. All right, if I've totally confused you, that's okay. I'm going to clear it up right now. That negative is important because that means that this person was losing followers over the course of the 5 years. Now, that should be obvious by the numbers. At time 0, they had more. At time 5, they had less. But again, the slope formula is meant to give us and tell us whether or not something is a positive slope or a negative slope. So if I didn't have this information, I just had what was shown here, I could still determine that over the course of those 5 years, they were losing followers. All right, there's your yearly rate of change. Explain your answer. If you want to write something down, go ahead. I think I just explained it well enough that I'm not going to for the sake of time. So, another one. The graph at right shows the population growth of China. It says find the rate of change from 1950 to 1975. Well, here is our number at 1950. Here's our number at 1975. Much like that word problem from before, I like to pull out the information I need and then not deal with the picture again. So, in 1950, the people in billions was 0.55. In 1975, the population was 0.93. So I'm going to go ahead and calculate that slope just as I've been doing. I'm going to use this as my y1 and this as my y2 just because I don't like working with negative numbers. 0.93 minus 0.55 divided by 1975 minus 1950. That becomes 0.38 divided by 25. And when I plug that into a calculator, I get 0.0152. So that doesn't really mean much as a number, but in the context of the problem, that means the rate of change from 1950 to 1975 was changing by about 0.0152 billion people over the course of 25 years. All right, if you're confident with the way I did A, go ahead and try B, and if you'd like, you can even write down some explanation here while you're waiting. Otherwise, I will go through that example right now for the rest of you who aren't quite confident yet, which is totally okay. 1975, our population was 0.93 again. Says to go to 2000, so in time 2000, we were at 1.24. Pretty big jump. I'm going to use that as 0.1 and that as 0.2. 1.24 minus 0.93. Divided by 2,000 minus 1975. I guess I could have just put 25 down there. No big deal. I throw that in my calculator, and I get 0.31 divided by 25, and then I put it in my calculator again and get a rate of change of 0.0124 billion people over the course of 25 years. So that doesn't make a lot of sense in billions, because that's billion per 25 years. If you converted that out of billions, it would make a little bit more sense. So if you want to go ahead and do that, I encourage you to do so so that it makes more sense to you. So explain the meaning of slope in each case. I did that a little bit for both of them, but let's just take C to kind of compare and contrast. Which one of these had the greater rate of change, meaning which one had a larger slope? Just looking at the numbers, it would look like we had a greater rate of change from 1950 to 1975, meaning in those years, the population was growing faster than it was between 1975 and 2000. It's really hard to see in this graph. It's one of the reasons why graphs can be a little bit misleading, and also why we want to look at things in two different ways. We like to look at the raw numbers as well as the graphs to tell us the information that we're looking for. So there's just a little bit more on slope. Tomorrow we're going to jump into direct variation, so if you have any questions, don't hesitate to let me know.